So in this video, I'm going to talk about the introductions of distance formula. And distance formula is one of the most important formula, important thing that we should learn. And for distance formula, there are a bunch of ways of doing it. But in this video, I'm just gonna do a introductions, and in the future video, we're going to solve some problems about distance formula. But this is just the introduction. So here is our coordinate plane right over here. And for our coordinate plane, let's say there is a 2 point. So 2 point, 3 comma negative 4. So 3 comma negative 4. We go down 4. At this point, it is 3 comma. So 3 comma negative 4. And for the other point, let's say it is 6 comma 0. So 3, 4, 5, 6 and 6 comma 0. And we want to find the distance between these points, which means if we connect the line straightly, we want to find this line's length, which means there's distance between 2 points. Well, there are a lot of ways for approaching this question, but we're going to talk about Pythagorean theorem. And people usually say that, well, there is no triangle, and how can he relate it to the Pythagorean theorem? But if there is no triangle, we can make it by making a straight line. And this is going to be clearly a right triangle, since we know that there's a right angle right over here. So write down again. So right angle, and this is our distance. And so let me erase this. So we know that this term right over here, it is a change in x, because it is the reason why it is changing x. This is a delta sign, which means the fancy way of writing the changing x, because it is changing to the x direction. What about this point? It is changing y, because it is changing into y direction. It is going down. So for this, we can solve for Pythagorean theorem. And for Pythagorean theorem, it is a squared plus b squared should be equal to c squared, where c is a hypotenuse, which is the longest side of the right triangle. And we can only apply this Pythagorean theorem when it is only right triangle, and the c should always be the opposite side of the right angle, which in this case d. So we can say that distance squared should be equal to a squared plus b squared, which is x. In this case, changing x and changing y. So changing x plus changing y. And we can just replace changing x value into 3. So 1, 2, 3. 3. Oh, but it should be squared. So 3, and then for changing y into 4. It is negative 4, but we don't care about it because we're going to square it, and minus times minus, we're going to be positive, so we're just writing in positive. So we can say that d squared should be equal to 3 squared, which is 9, plus the 4 squared, which is 16, and we can see that it is 25, and so d squared is 25, and we can take principal root. We can take principal root of it, square root of the both sides. And we are only caring about the positive value, not a negative value, because we're finding a distance. So we can see that square root and the square root, we're going to cancel out. D should be equal to 5 times 5 square is 25. So square root of 25, we're going to be D is equal to 5. So we figure out the distance between these points. It is equal to 5. And there is another way of solving for this problem. It is just using a distance formula, but the reason why I apply this Pythagorean theorem is because to easily understand about distance formula. And the distance formula I'm going to introduce it. It is d squared should be equal to square root of x2 minus x of 1. All of that squared plus y2 minus y to the 1 squared. And people see what is wrong with this x2 and y2 and then x1 sorry, it should be y, it should be x, yeah, it should be x1 and then y1. Well, we know that we can only simplify with the like terms, which is in this case x2 and x1, y2 and y1. The y2 and y1, x2 and x1 are just a coordinates of the 2 points, which means if there's a point x2 comma y2, and there is some point x1 and the y1. And then we are trying to find a distance, and the distance formula, we can do it. We can apply this distance formula for it. So if we can, so it should be d, not distance. I'm confusing. And we can take square to the both sides in order to cancel out these radicals. And then we will get d squared should be equal to radical and the square we're going to cancel out. And x2 minus x1 squared plus y2 minus y1 squared. We know that x2 and y2 and there are those order, even though if we change, it's no matter because we are taking square. Even though we became negative, it will gonna be positive in conclusion. So I'm going to plot some points to apply this. So let me erase this. So I'm going to erase this. Okay. So let's say there is a point 1 comma 7, so 1 comma 7, so 1 comma 7, 3, 1 2 3 4 5 6, we need to go one more. So this point right over here, it is 1 comma 7, so it is 1 comma 7, and let's say we have some point negative 6 comma negative 4, so negative 6 comma negative 4 here, and we want to find a distance between these 2 points. So we want to find the distance between 2 points. Instead of using a Pythagorean theorem because the value we're gonna be large, we can apply this this term right over here. So at first I'm gonna call this x2 and then x and the y2. The order does not matter, so I'll just randomly doing it. So so we were going to be x to 1 comma y to the 1. So this is a coordinates, and we can apply this. So d squared should be equal to x2 as x2. It's going to be 1 minus, well, this coordinate is, we know that this coordinate is negative 6 comma negative 4. So 1 minus x1, which is negative 6, and all of the square plus y2, which we're gonna be equal to 7, then minus negative 4, so minus negative 4 to the square. And we finished with the equation, so let's simplify it. So we're going to say that d squared should be equal to 1 minus will turn into positive, so we're going to be 7 squared, which is 49. Plus 7 minus will turn into positive, so it'll be 7 plus 4, which we're going to be 11. And all of the 11, which if we but we need to be careful with the square, which we're going to be 11 times 11, which we're going to be 121. And if we add up these things right over here, if we add up these things, it will going to be equal to d squared should be equal to 121 plus 49 should be equal to 0, 6, so 170. So we're going to be 170. So I'll write this down. So, but d squares are equal to 170, not d. So we need to take square to the both sides. So the square and the square root will cancel out. We get d should be equal to square root of 170. And we get 170 right over here. It is approximately 13.04. This was our answer for it. And in this video, it was just the introduction of the distance formula. And we used the one way of Pythagorean theorem and another way of the distance formula. But Pythagorean theorem is kind of hard to do it in the real question if they didn't give us a coordinate. So in the next video, I'm going to talk about the first example of solving for a distance question using the distance formula.